There we go. We are recording. So let me get that back down. Get the problem pulled back up. I don't have screens to work with here, so y'all just gonna have to bear with me a minute. Tim, I need more equipment. Oh, he's already listening.
Tim's gone.
Okay. Well, y'all need to tell him I need more equipment. I need more toys.
What you need, I'll put in a word.
Yeah, put in a request for me. I'm sure on this T-Rex campus, T-Rex college, I'll get it. I was told I couldn't do this. That's what I was told. We're currently not doing this, okay? So we've got a graph that I'm trying to think if I can actually do this. No, I can't. I probably go ahead and don't worry about writing the answers. We're going to talk about that in just a minute. Just write using a visual observation, determine whether the graph is symmetric with respect to the x-axis, the y-axis, or the origin. Okay, so right quick, just write that down and then sketch the graph. You don't have to write the other stuff, okay? And I'm going to, hopefully y'all got most of it written down. I'm coming back to it. I'm going to try something. I want to see if I got the whiteboard on this laptop. I got the whiteboard on here. I don't see it. Oh, dog it. I thought I had it on here. Epson. Nope, I sure don't. Well, I got the Active Inspire, but I don't know. I can't make it transparent because this is like old school. Okay, I can't make that transparent. Just give me a second. I'm trying to see if I can do this. Before we had the Epson, the projector that you see on top of the ceiling up there, we had this old school smart board, and I don't think I can do it. It's clear. Hold on. Clear. No, no, I can't do it. It's old school. Okay. All right, so forget that idea. I'll just do the best I can with it. Let's go back to the question. This is a trial anyway. This is just something to see if we can actually do it. So I think this is a pretty good. Hold on a second. I'm pulling up the camera. There we go. And I'm going to have to make it small for a second. And move it over. There we go. And I'm going to take and draw the graph like so. And I'm going to do -2 pi and -pi and 0. And this is 3, 1, 2, 3. That old sine curve, 2 pi, pi, and we've got going up here, going down here, up here, something like that. All right, it ain't gonna be perfect, but it's hopefully gonna. Like that. Okay? So can y'all see that pretty good?
Yes, sir.
Okay, good. Now, what does symmetrical mean? Symmetrical means that it's a mirror what?
Image.
A mirror image. So right now, if you just took this away, is that a mirror image? Yes or no? Yes, it's a mirror image around the what axis?
Y.
Y or X?
X.
X. This is the x-axis. And this looks like this. And then you got to turn here, you got to turn here. And then this looks like this. All right? Now, what I mean a mirror image is the contours of this parabola here looks like the contours of this parabola here. Yes, they're going in the opposite direction, but that's what the x-axis does. It changes it, okay? But you have the mirror image versus something like this, which would look, if I had, can't think of anything right now coming off the top of my head. If I had this right here and this right here, is that symmetrical? No, that's not symmetrical, but this is. All right, so you've got, it looks like it's symmetrical around the x-axis, but not, you could say it's not symmetrical, because if you flipped this around the y-axis, what would it look like? It would look like that, wouldn't it? So you could say, I don't think you could say it's around the y-axis, but you could say around the what? What's the origin? There's the origin. Does this look like this? Yes or no?
Yes.
You could say it's an argument for the origin and the x-axis. Okay? You could make an argument. All right? So let's see and that's why graphing, there's an algebraic way to do it, and then there is a graphic way to do it. It says, yes, it says around, okay, we're answering A, x-axis. Is it symmetrical? Now, the argument could be that if they're asking for symmetrical, they're asking if it's symmetrical around the y-axis, if it's, and I'm going to show you this. The way the question's asked in the context of the question seems like it's asking if it's symmetrical like this. Like that right there. And of course you would say no. Okay? What's this one doing? It's flipping it, but what's it doing after it flips it? It flips it another direction. So I would say it's probably, it is symmetrical around the origin and the x-axis, but not just one. Okay? Not just one, because you're flipping it around two things. You're flipping it around the x-axis, and then you're flipping it around the origin. So just like right here. What's happening here? You're flipping it around the origin, and then you're flipping it around the x-axis. So you're here and flipping it. So you can make an argument on that. So I would say just around the x-axis, you could say no. All right? Because for pi over 2, 3, the point pi over 2, negative 3 is not on the graph. That's what I would say just for the x-axis. All right? Let's see what no, because for pi over 2 over 3, pi over 2 comma 3, the point negative pi over 2. Well, let's look and see which one that is. Now, I'm pointing, you can't see me, but I'm pointing at the graph. I want everybody to look at pi over 2 and 3. That's pi over 2 and 3. That's the vertex of the first hump right there. All right? Now, when you flip that over and go automatically down, that's going to be pi over 2 and negative 3. It's not going to be negative pi over 2. So if you go around the x-axis, it should be pi over 2 negative 3. But it's not there. So you would say no. At least that's what I would say, because It's not around the x-axis. Okay, and we got that correct. Now, what about the y-axis? If you flip this over, okay, I'm going to go back to my camera. I'm just going to show you this right here. Can everybody see that, Pendleton, Oconee?
Yeah.
Yes, sir.
Okay. If you flip this point right here, if you flip it over the y-axis, is there a point there? No. So it is not symmetrical because what's this point? This point is pi over 2, 3. This would be negative what? That's pi over 2 right here. Negative pi over 2, that was a yawn, I believe. 3, positive 3. Negative pi over 2 and 3 does not exist. So look, where does it say negative pi over 2 does not exist? Well, it's right here, A. So that would be no. Now, what about the origin? Okay, let's look and see. Now, they're asking here, I'm going to bring up the camera again. I wish I could put this camera. Let me see if I could put it in the bottom right-hand corner. There we go. Let's try that. Okay. All right. Let's take, and I'm going to use my red pen here. Let's take this piece right here. And let's flip it around the origin. Let's flip it like bing, right here. Bing, like that. Is this point over here? Yes or no? Yes, it is. It's right there. So this is pi over 2. So we are looking for yes. Pi over 2, 3 is negative pi over 2, what? Negative 3. Everybody get that? So let's see what it says. Yes, because blah, blah, blah is negative A, negative B. Do we need negative or negative? Yes, because it's in the what quadrant? Third quadrant. So I would say yes, B. Bravo. So B and check answer. And we are done with that question. So when you think of a question like this, and this is a good test question, it's not a perfect test question, but it's a good test question. You have to take each one step by what? Step by step, Hubert. Thank you, class. All right, you can't just say, well, is it symmetrical? No, you have to think around the x-axis, the y-axis, and the origin. All right, and it has to be a mirror image. Now, the mirror image is on the origin. And I got a question on that one.
No.
Okay, everybody feel good about it?
Yeah.
Okay.
Yes, sir.
Let's go with another one. Let's see. Mr. Bays is working on his homework. Let's see. 1 point. Okay, we just did that one. Okay, this is 2.149/10. It takes a minute here because I'm in another state, so I guess it has to take longer. Well, hopefully it'll come up eventually. There we go. All right, here's another symmetry problem. Okay, where's my camera? Camera, there we go. All right, this problem has, oops, I can't move it, I gotta move this down. Y'all bear with me, I'm doing this for y'all, so don't get mad at me. All right, here we go. We've got a graph, and we've got a point right in the origin, and then we're going up to 2 and 1. And then we're going down to, what is that, 4 and -5. Y'all settle down. Going down to 5, there we go. So that's what that looks like. Now, what is it asking? It's asking f of -x. It says complete the left half of the graph This is y is equal to f of x. So this is y equal to f of x. So that means, let's write down the points. Y'all ready to write down the points? What's the first point? 0, what? 0. What's the second point? 2, 1. What's the third point? 4, what'd I say? 4, negative 5. Everybody with me?
Mm-hmm.
This actually says y is equal to x. Or, no, okay. No, it's not. No, shut up, Hubert. All right, so if whatever the function is, we don't know what the function is. When you plug in 0, you get 0. When you plug in 2, you get 1. When you plug in 4, you get negative 5. Everybody with me?
Yes, sir.
Thank you, one person. Okay. So here and here. Pendleton, Oconee, Miss Whiten, you there?
Yeah.
Okay, she don't sound too happy. You don't sound. What's wrong, Miss Whiten? Is life getting to you? What's wrong?
No, I just have a cold. And
Oh, you got. I do too. I got allergies, real bad. Okay. Now let's take a look at what this says over here. It says we want to know if f of negative x is equal to f of x. Well, that's like saying negative y is equal to f of x, right? That's what that's saying, basically. So they're asking you which one gives us, okay, that means that the y, this y right here, is not going to change, okay? So that means 0 is not going to change, 1's not going to change, and negative 5's not going to change. So everybody see where I'm getting that?
Mm-hmm.
Because what's the only thing that's changing? This side over here. It says f of negative x. Okay? So that means that all our numbers on the left are going to turn into what?
Negative numbers.
Okay, so that 0, it doesn't affect 0, but what does that 2 turn into? A negative, and that 4 turns into a negative. So let's graph these points. That one goes there. Negative 2, positive 1. And negative 4, negative 5. So which one is it? It should be A, Hubert. That's right, class. Good. You know, y'all suck. All right, check answer. Nice work, Hubert. Okay, I'm gonna go to the screen here. I'm gonna make sure. Are y'all awake or what?
Yes, sir.
Okay, I understand Pendleton not talking. They don't talk to anybody. Okay, Miss Whiten, she's hungover. But Anderson campus, y'all can do a little bit better than that. All right, just because I'm not there doesn't mean that y'all can clam up. All right, Miss Mays, are you hungover too?
Yes.
Okay. All right. Everybody's hungover. All right. Let's go back to where we were. All right. What is f of negative x is equal to f of negative x? Well, that means both sides are going to change. All right. So f of negative x we got right here, right? This is f of negative x. So I'm going to take another color. Dang old lavender. Dang old Squidward loves lavender. Lilac. All right. So f of negative x we said was 0, negative 2, and negative 4. So what is the negative f of x going to be? 0 is not going to affect. What about the 1? What's it going to make the 1?
Negative 1.
And what's it going to make the negative 5?
5.
Y'all are so smart. So 0, 0 is right here. And negative 2, negative 1, negative 2, negative 4, positive 5. Negative 4, positive 5. Up here somewhere. So which one is that one? B, Hubert. That's right, class. Can y'all not see these
B.
graphs right here? Or y'all just ignoring me?
B.
We couldn't see what you were writing.
Yeah, I
Oh,
can't
I'm
see it.
sorry. I suck. There we go. Let me pull this up a little bit. Hold
Oh,
on.
that's-
Can't slide this time.
There we go. There it's in lavender right here.
Okay.
I don't have my screens. I can't. I'm having to deal with one screen. All right. I did it in lavender right here. 0, 1. Now, what is the lavender look like compared to the red?
B. B.
Yeah, B. Y'all so smart. And y'all feel good about yourself. Question. Okay, let's go over the next one. Since we're not doing this, we can't do this. 2.1, 61 slash, you brought me a biscuit. Dadgummit. I can't eat the bread, but I would eat the chicken or the sausage.
Oh, yeah.
I didn't bring it.
Oh, you didn't?
I didn't.
Okay, you suck.
I was just trying to get your attention in the email.
Okay. Each function is either even or odd. Use f of -8 to state which situation applies. Now, I don't know where it is in your book. Let's find it. Let's go to our handy dandy here, and this is not 110. Oh my God, we gotta wait.
20 seconds.
Oh, we're not doing this. We can't do this. We need to go to somebody look up if you've got a book. Any of y'all have a book? Look up even / odd in the index or in somewhere. I don't know what section we're on. What section did that homework come from that you sent? 2.2 or 2.1 or 2. What?
2.1.
Okay, look in 2.1 section and find the page number that has even and odd on it. And tell me what page that's on, please. Well, I'm trying to get there. Chapter contents.
99 maybe?
Okay, let me look at it. Ink text. Because this is what you need to write down. And this is, remember when I said you could find if something is symmetrical either by the graph or algebraically? This is how you find it algebraically, if it ever comes up. We are waiting. Oh, pop-up locked. And hopefully that will bring it up, since we can't do this.
He is drunk.
What'd he say? What he said. Somebody's going to have to repeat what he said.
Oh, I said you must be drunk.
I am. That was the last of the cranberry and vodka. I don't even drink vodka. I don't like it. Never have liked it. Cranberry juice in my water. I call it cranberry juice and water and vodka. So
Why do you put water in your cranberry juice?
I have drank.
Unless, man.
The first time I ever drank vodka was in high school, and I drank so much of it I got sick, and I never did drink any more of it. And I don't think I've had a drink of vodka since high school. Kind of like when you drink too much grape juice or you eat too much candy or whatever, you get sick and you never eat it anymore. I actually knew somebody that ate too much watermelon. And they'd eat watermelon the rest of their life. Anybody ever done anything like that?
Yeah.
Can't say I have.
I got into my mama's cabinet, and I think it was her wine cabinet, and she had some homemade wine or blackberry wine. I thought it was grape juice. Oh, Lord. Off of it, and got sick, threw up all over the place. And this day, I won't drink. If you give me grape juice, I won't even look at it. I won't even, ugh. Not working. Y'all not going to talk to me, so.
Go back to the thing where it shows the pop-up box.
I did it twice. Okay, what page?
The Russian.
Well, it says it's not needing to pop up. I'm going to pull it up again. See if it'll work. I just wanted to pull it up so you would have it. Well, while that's doing it, I'm just going to go over here, and I'm going to pull up even symmetry. How do you spell symmetry? There it is. Even odd symmetry. And I'll just do it the Google way. Image. And maybe, no. That's not what I want. Or so you'll have it so you can write it down, and I can't pull up, let's see, roll. I think this is it right here. There it is. That's there or here. I'll see which one's better. Okay, there we go. All right, write that. Let's see. Save image. Give me a second. Even, odd, save. That's under my pictures. Go to my handy dandy old ass whiteboard. Dang, where is it? Excuse me, I'm doing this so I don't have to cancel class and doing just see if it can be done since somebody told me it couldn't be done. But really do this, but
I think you're just doing it because someone told you you could.
just give it a second. It's coming up. You are supposed to be impressed.
Tell the truth. Are you wearing pants?
Yes, I'm wearing pants. I gotta go to a conference after I finish classes. Be quiet.
How'd it go?
Sound like y'all drinking something. There we go. See there, aren't y'all impressed?
Oh, yeah.
Okay, write those two down. I'll take my handy dandy highlighter. And I think I can draw a straight line on this thing. I hadn't used this in Coon's age. Oops! Messed up. Oh, Lord, how do I fix this? There it is. I'm not going to do that. Go ahead and write the two. There's my highlighter. Go ahead and write this function down and write this function down. And what page you say this was on?
98, 99.
Okay, just look at page 98 and 99 because that's what they're talking about right here. To algebraically tell if something is symmetrical to the origin, f of negative x is equal to negative f of x. And I'll show you in this problem that Mr. Bays sent, I'll show you what I'm talking about. If the function is even, That means it's symmetrical to the what axis? To the y-axis, Hubert. That's right. So that means it flips. It's a mirror image around the y-axis or the origin. And if it's not those two things, it's what?
Neither.
Neither. Okay, so I'm going to write that down on this handy-dandy pad. Odd is f of negative x is equal to negative f of x. And even, I'll put it at the top. Even means that f of negative x should be equal to f of x, I think. Yep. And even is around the y-axis, and odd is around the origin. Remember, that's an easy way to remember. I don't know if you know how the easy way, but O and origin, that's probably the easy way to remember. Okay, now the question that you asked is now gone. I don't know where it went. Well, pull it back up. It's pulling it back up, so just give it a second. All right, the question that you asked was, is the function 7x to the third minus 3x? So write that down. So I'm going to write it down. 7x, f of x, is equal to 7x to the third minus 3x. All right, tell me what this means. That I underline. Tell me what f of negative x means. What does f of 2 mean? That's not rhetorical. I want y'all to answer it.
X equals 2.
That means that wherever there's an x, you plug in a 2, right? So what does f of negative x mean? Wherever there's an x, you plug in what?
A negative X.
Okay, so let's do that. So I'm going to check to see if it's odd down here. This is our odd test. Wherever there's an x, I'm going to rewrite the problem. 7 times parentheses cubed minus 3 times parentheses, because y'all know me. If you plug in something, I'm going to use parentheses because I don't want to mess it up. And what am I going to plug in? I'm going to plug in what? Negative x. Now, somebody tell me what, I'm going to use a different color. Somebody tell me what this means.
Same thing.
What does that mean if you have a negative in front of the function? That means you have a negative in front of the what? Function, and you distribute a -1. Everybody with me?
Yeah.
This right here means -1 times f of x, and you distribute that 1. So I'm going to say equals. I'm going to do equals in black. And then I'm going to go, okay, that means I've got to put a -1 in front of what? 7x to the third minus 3x. Now all you have to do is your pre-algebra and see if they're equal to each other. So do that. Actually, I'd rather teach the course and go to the conference, but
Have a conference.
It's a government conference. I'm part of the county government, Anderson County, and it's a ACOG, Association of County Governments.
Sounds exciting.
Oh yeah, about like watching paint dry. Okay, so what happens? What is negative x to the third power?
Negative x.
What's 7 times negative x?
Negative.
X.
Negative 7x. So this comes out to be negative 7x cubed. Or you could say 7 times negative x cubed, but that turns out to be negative 7x cubed. What's negative 3 times negative x?
3x.
3x. What's negative times positive 7?
Negative 7.
7.
And what's negative times a negative?
Positive.
Positive.
Oh my gosh. What happened? They're what? They're equal.
Equal.
So that means that this function is a what function?
Odd.
It's an odd function, which means that it is symmetrical. I don't know how to spell symmetrical. It is symmetrical around the what?
Origin.
And if you check that on your graphing calculator, you'll see it's a cube. What kind of function is it? It's a cubic. Hey, I remember my parent graphs, Hubert. Let's see. Graph like that. The origin. This is how you tell graphically, and this is how you tell algebraically. And if it's not these two, well, what if it wasn't this one? Then you try this one. And if it's not this one, then it's what?
Neither.
Very used question on any standardized test, and yes, you will see it on my test. Not a lot, probably 1 or 2 questions, but not a lot. But that is a very, very used standardized test question. So for anybody that's going to be taking an employment exam, anybody that's going to be taking an entry exam into another college, anybody going to take a GRE for a master's program, you would see this standardized test. It would be just like this. It would say each function is either, or it would say determine if f of x is even or odd or neither. It'll say something like that. Function is odd because negative x is equal to negative f of x. Feel good about yourself?
Yep.
$1,000 worth of rims on a $1,000 car. Yep, do that, right?
Right.
Okay, y'all just gonna ignore me? Okay, that's fine. Slash 18. 77/18. And by next determine whether the graph of the given function is symmetric, but if it's odd, even. Do it. Check it with your graphing calculator. I hope we have a graphing calculator on this. I think I do have it on here. So I'm going to take my handy dandy and I'm going to tear this off. And we're going to put f of x is equal to and my rule says that I need to check and see negative x and and that's to see if it's odd. And then if that's not true, I check to see if it's even, and even is f of negative x is equal to f of x. Take a minute and do that. I sent out I created a GoFundMe page.
For what?
I can't tell you.
Right?
It's a GoFundMe page to build the damn wall. I created it today. I'm wondering if it's going to work. Nope, it's not going to work so far. Do you realize if the people that voted for Trump, if they would give $50 a piece, they could build the damn wall? But that's just like telling rich people that fuss about social equality to give up 3/4 of their paycheck.
Ooh.
They won't do it. So. Where's the Sharknado? Where's it gonna hit?
Myrtle Beach.
It's gonna hit Myrtle? I thought it was gonna hit Wilmington.
Supposed to hit Charleston too.
Oh, it's gonna hit Greenville. The only county it's gonna hit is Greenville because WYFF is sending out survival kits. You got to get bread and milk too. If you don't get bread and milk, you're gonna die.
I don't know what is up with that.
If you're in South Carolina, if there's anything that happens, you go buy bread and milk. And you run around in circles hysterically.
Yeah. Pretty much.
Or this is the best way. Or you say you're going to fight it out and stay in your home, which you're in a floodplain anyway, and you stay in your home, and then you complain that the government didn't take care of you while you're sitting on top of your house. That's what irritated me about a lot of people in past storms. They fuss about the government not getting them out of the flood. Well, it's kind of like, it's kind of like that joke where the guy said that he was going to stay during the flood and God would take care of him. And the waters kept rising and the waters kept rising and he got on top of his house. And the guy on the boat came by and said, "Here, we need you. We need you to get off your house." "No, God will take care of me." And then a helicopter came by and said, "Here, we'll drop you a rope and we'll pick you up." "No, God will take care of me." Well, dumbass died. He drowned. And he went to heaven and he said, "God, why didn't you take care of me?" He said, "You dumbass, I sent you a boat and a helicopter." Well, that's what these people do. They say, "Oh, I'm going to fight it out. I'm going to stay at my house." And then who do they complain? The first person they complain to is the government. They didn't save me. I don't understand. Dang live PD. All right. So I'm going to write my function down. And instead of over here, instead of writing it down with x's, I'm going to write what? Parentheses to the 6th power minus 6 times parentheses squared equals negative parentheses x to 6 minus 6x squared. And what am I going to plug in to those parentheses? A negative what?
Negative x.
Negative x. What is anything raised to an even power?
Even. I mean, positive.
Positive. So that's going to make it x squared to the 6th. And what is negative x squared? X squared, and what's x squared times negative? Equals negative x to the 6th plus what? That's not what? That's not equal. So you quit, right?
Nope.
No, you go over here. Now the good part is you don't have to do any work. Why? You already know what f of negative x is, don't you? F of negative x is what? X to the 6th minus 6x squared. And what's f of x?
X to the 6 minus 6x squared.
Oh my goodness. Look at that. So this is a what function?
Even.
So let's check it out with our handy dandy calculator. Let's take our handy dandy calculator, which I hope I had installed on my laptop. Anybody see a calculator?
Nope.
Dang it. I thought I had it on here. I don't have anything on this laptop. Okay, well y'all need to graph it.
I think you can Google a graphing calculator if you
Try it.
like. Really
Yeah, you can.
What are y'all doing? Who is moving around? Graphing calculator. No coughing in class. Where is it coming? Where is it? Is it online or what? Let me hit online. It on my computer. Oh my Lord, just somebody can use it. All right, did anybody graph it? I'm not gonna worry about this because I'll have to go put in my email address and stand on my head 3 times. So just let's see. F of negative, that means it's even. It's symmetric around the what axis?
Y.
Where does it say the y-axis? Here it is. How about C?
E.
Y'all agree with that?
Yeah.
Well, let's talk about let's talk to our family of graphs. What does our x to the even function look like? Is it symmetric around the y-axis?
Yes.
Yeah.
It is. So, oh, I'm sorry. Hold on. No. I'm not used to these things that I'm dealing with. There we go. So it is symmetric around the y-axis because we said that these two are equal. So that means it's symmetric around the y-axis. How you feel about that? That makes you feel a little bit better about yourselves?
Mm-hmm.
Yes, sir.
Good. Guys, they ain't gonna talk. Mr. Bays, does that help out a little bit?
Yes.
2.2. This is 2.2 48/10. Who's the dog to play next?
Nobody, Middle Tennessee.
Oh, they playing another cupcake bowl.
Yeah. This week.
Well, who does Alabama play?
Nobody.
Again?
Yeah.
How about Clemson?
Nobody.
It's gonna be
It's
a,
another nobody week. Yeah.
I think when does LSU play Auburn?
This week.
That's it. That's the one that's this week. That's what everybody's going to be watching. All right. This one says graph the following. Oh my gosh. This is a what? Parent graph. Absolute value means absolute what? Vodka. So this is the parent graph of what? Vodka. V. So the parent graph looks like that. Looks like a V. So what does that 3 tell you?
And that's the vertical increase.
Okay, how do you know it's a vertical shift? How do you know it's not the horizontal shift? You're right. You're correct, what you just said. But how do you know?
Because it's not inside of the absolute value symbol.
I'm just amazed. I am amazed. That's what it means. This is what it would look like if it was a horizontal shift. Y is equal to absolute value of x minus 6 plus 4. That's what a horizontal shift would look like. Remember, always remember this when you're talking about a horizontal shift. The horizontal shift will always be connected to the what? The x. Write that down. The horizontal shift will always be connected to the x. What do you mean connected, Hubert? Well, is the 3 connected to the x, or is the 3 connected to the function?
It's
The 3 is connected to the function because the actual function is what? The absolute value of x. Yes, that's right. See, if the 3 was connected to the x, it would be inside the absolute value marks. That's how you discern if it's a horizontal shift or a vertical shift. Let me show you what I'm talking about. If I gave you y is equal to x squared plus 3, is 3 a horizontal or vertical shift?
Vertical.
Vertical because it's connected to the what? The function. The function is x squared. The function is what represents the parent graphs that I gave you. So what about this? Y is equal to 1/3, 1 over x plus 3 minus 7. That's a 1 right there. All right. What about that one? Well, the x is not, the 7 is connected to the function. The function is right here because the function is the parent graph 1 over what? X. Do you see what I'm saying when I say the function? The function is what's represented by the parent graphs, those 8 graphs that I gave you. Yes or no? Y'all remember those 8 graphs?
yeah.
Yes, sir.
Those are the functions. So if you got something inside that function, that's a horizontal shift. If you have something outside that function, it is a vertical shift. I'm going to take my red marker and I'm going to draw this function is the absolute value of x plus 3. So we have discerned that the plus 3 is a vertical shift. This is 1, so that means it's identical to the black parent graph. It's the same graph except 3 what? Up. And that's what it should look like. So how do you draw that? Well, you click on to click, enlarge, and then it's going to ask you to draw absolute value, and then you're going to put the vertex at 3, and then you're just going to draw a regular 1-to-1, and then hit save, and then feel good about yourself.
So absolute value questions are always about the vertex?
Always about the V, the function, the V. This is V right here, yes. Turn to that page, it's got the 8 parent graphs on it. Okay? Anything having to do with absolute value is going to look like a V. Anything having to do with a squared function is going to look like a parabola. Anything that looks like a 1 over x squared function is going to look like the volcano. Okay? That's why I gave y'all the parent graphs,
Yeah.
so you can memorize them.
Are they in our book or in the ebook?
Somebody look in your book, and it should have them. I think they have them separately within the pages, but I think they have them on one page at the very end. I think they have all of them on one page. That would be 2.2 or 2.3, wherever this question, 2.2. Look in 2.2, and somebody tell me what pages they're on. Anybody see it yet?
Still trying to load.
People are asleep. Is Pendleton still awake?
Yes, sir.
Okay, still got one spokesman for Pendleton. Let me ask you something, Miss Shuttleworth. Do they actually talk before class?
No, sir.
Pendleton, do y'all just want to antagonize me? Is that what it is?
At this point, it's getting funny.
That's all right. I'll do a bonus question worth 10 points on your next test, and everybody's got to tell me the answer. I guarantee you they'll talk then. There's nothing I can do about it. They're not going to talk to me, so. Anybody find the page number?
Not yet.
Okay, well, you just have to look through 2.2 or 2.1. I don't know where they are, but that's why I gave y'all the graphs. That's why I gave y'all the parent graphs that day. Do you have them, Mr. Bays?
No, it's still trying to load the page.
No, do you have them in your notes? Were you absent that day or something?
Well, I've got half of them, but the next class, I guess you probably finished them up, and I only have 4 of them.
Okay, well, here we go. I'll write them right quick for you. They're not going to be pretty, but I'll do them right quick for you.
If they're not pretty, I don't want them.
Okay, well, I'm sorry. You can be a diva somewhere else, okay? All right.
Do better, man. Just do better.
All right, so f of x is equal to x to the first power. I'm going to try to do this as fast as possible because some of y'all are going to start going into convulsions soon. Anytime you got x to the first power, it's going to be a what? Great question. F of x is equal to x squared. It's going to be a what?
Parabola.
Parabola or parabola. Did I tell y'all about me saying parabola in Dr. Gabati's class?
Yeah.
Mr. McClure, I do not understand what you are saying. That there's a parabola. Parabola. The sad part of it is I thought I was correct. I thought I was saying it right. X to the third. Well, there's old saying, don't ever forget where you come from or you're going to forget who you are. All right. So f(x), that's x to the third. F of x is equal to x to the even power, meaning 4th, 6th, 8th. It's going to be what? What's the difference between a parabola and a quartic function like 4, 6, 8, 10? What's the difference?
Nothing.
The bottom is going to be what? More squared, but you're still going to have what? A parabola. But the bottom is going to be, the higher the degree, the higher the variable, the more you're going to have a square on the bottom. But it's still a parabola. Now, there's also 2 things that you need to make sure of. You know what ending behavior. Ending behavior. Ending behavior. What is ending behavior? Well, sometimes a question will ask for what is the function depending on its ending behavior. When you have x to an odd power, the ending behavior is going to be two arrows going which way? Opposite directions, like that. When you have a function with an even exponent, what's the ending behavior?
Going
They go in the same direction.
yeah.
So I may ask you a question on the test, and I may ask ending behavior of f of x is equal to x to the 16th power. And all you have to do is just pick the one that looks like what? Like that. Because if it's an even power, it's going to look like this. If it's odd power, it's going to look like what? It's going to look like that.
So if it's a higher odd exponent, does it matter?
Nope. They're all going to look like that. Now, I'm not talking about radicals. I'm not talking about fractions. I'm just talking about an x raised to an even power, x raised to an odd power. Okay? Now, let's move down to the bottom. Now, I might get the next two mismatched. Sometimes I put one before the other, but it doesn't matter. I think the next one is f of x is equal to the square root of x.
Yeah.
Yes, sir.
And that's the line that goes to the right. So if I had the square root of x, and then it ended like this, and then I had a plus 1 out here, what would the plus 1 be? A vertical or a horizontal shift? It'd be a vertical shift because I got this little tag right here. And I had this plus 1. Now what if I had the plus 1 in the tag? Then that would be a horizontal shift because it's attached to the x, not the function. Next one, oops, f of x is equal to the absolute value of x. Absolute value, absolute vodka. Looks like a V. F of x is equal to 1 over x. That was half a volcano. So if that's half of a volcano, what does 1 over x squared look like? The whole volcano. And that's your parent graphs. I can't get them all on one page, I'm sorry. There we go, that's about as close as you can get. Comprende?
Mm-hmm.
Okay, guys, I'm going to let y'all go. And I don't know if it's early or not, but I'm going to let you go because this has been a success. Thank you very much. I will, listen to this, I'm going to give everybody an attendance for being here.